Ladies and gentlemen, boys and girls, children of all ages, these identities are the ones that give every trig student a great headache. They make things seem so difficult to you. It's like, how does this work? But in reality, if you can understand them, they're not really that hard at all. So we're going to take some time and look at what are called sum to product identities. And the key to proving a sum to product identity is to use the partner product to sum identity. And what we're going to look at is, how do I recognize what the partner product to sum identity is? So let's consider. We have the identity sine x minus sine y equals 2 sine x minus y over 2 cosine x plus y over 2. And as a little yellow dot saying, remember, use a product to sum that matches. Wait, how does it match? Oh, if you look back at your product to sums, you see you have a product to sum. You see you have some that involve sums of cosines, differences of cosines, sums of sines, and then you say, well, wait, I don't have any differences of sines. The key is to look at the more complicated side. You see, that's 2 times sine x minus y over 2 cosine x plus y over 2. That's a sine times a cosine. And then we have a product to sum identity that also involves a sine times a cosine. That's the one we want to use. So we take our expression and we substitute those angles, x minus y over 2 and x plus y over 2, in for alpha and beta in the sine alpha cosine beta identity. So it'll be 2 times 1/2 times the sine of the first angle plus the second angle plus the sine of the first angle minus the second angle. At any point in time as you're going through these, you probably want to write these down, so you might need to pause. But take some time and really process what we're doing at each step here. At this point, the 2 and the 1/2 easily cancel out, and then we simplify on the inside. So we can put those fractions all over the same denominator. The y's will cancel out, and so we'll have sine 2x over x, and then plus. And then over here, let's take a moment and think about that. We're going to need to distribute the negative sign. We can, again, because they're both halves, put those over the same denominator. And when we distribute the negative, we'd have x minus y minus x minus y, which would be a negative 2y over y. So we have sine of negative 2y over y. But sine of negative 2y, x over x is x. Sine of negative 2y over y is negative y. Looks all fine and dandy right now. Wait just 1 second. Sine of negative y, because sine is an odd function, is the same as the negative of sine of y. And now we have our identity. Sine x minus sine y is equal to 2 sine x minus y over 2 cosine x plus y over 2. And the key is you match up the sine and the cosine from that identity with the sine and the cosine from your product to sum identity. And now it's your turn. For you, turn in this problem. Show that cosine x plus cosine y is equal to 2 cosine x plus y over 2 cosine x minus y over 2. And just a little bit of help, you want to use the product to sum identity that matches. All right, we want to use the product to sum identity that matches our problem. Okay, hopefully this helps you as you tackle this. For very many trigonometry students, it's a very difficult set of identities. People really get bogged down with all the fractions. They find it a little confusing. But again, the key is to look at those the terms over there with the fractions and see what's it going to be. So we look at those guys, and so we're going to pick the product to sum identity that matches that. In other words, the one that has a cosine alpha and a cosine beta. And then it's just a matter of working it out and seeing that everything turns out the way we would hope it would. Okay, good luck. Till next time.